Hey everyone! Have you ever noticed something weird about ChatGPT, Claude, or any AI chatbot? Ask them the same question twice, and you get different answers every single time. Is it broken? Is it confused? Actually, no. It's brilliant design. Today, we're going on a journey from simple concepts to the deep technical magic that makes AI feel, well, human. Buckle up, because this is going to blow your mind. Let me show you what's actually happening inside the AI's brain. Imagine I type, "The weather is." Now, pause for a second. What word would you say next? Sunny? Beautiful? Nice? Here's the thing. The AI is thinking about all of these at once. Look at this. It has sunny at 28%, beautiful at 22%, nice at 18%, all the way down to amazing at just 2%. The AI isn't picking the obvious choice every time. It's rolling the dice among these options. That's why you get sunny one time, beautiful another time, and sometimes even amazing, even though it's less likely. This is the secret sauce.
So, how does the AI decide how random to be? Enter temperature. Think of it like a dial. Turn it down to freezing, near zero, and the AI becomes super predictable. It'll pick sunny almost every time because that's the highest probability. Boring, right? Now crank it up to hot, and suddenly the AI gets creative. It might pick wonderful or amazing, even though they're less likely. This is why creative writing uses high temperature, but coding uses low temperature. You want your code to work, not to be creative. Most chatbots use a balanced temperature in the middle, giving you that sweet spot between reliable and interesting. Let's zoom out and see the big picture. Every single word the AI considers has a probability, shown by these bars. The AI calculates probabilities for thousands of words in its vocabulary. But here's the magic. Instead of always climbing to the tallest bar like a boring robot, it samples based on these probabilities. Higher bars get picked more often, but shorter bars still have a chance. It's like a weighted lottery, and this lottery happens for every single word. That's why you get different, natural-sounding responses.
All right, you've got the basics, but now we're going deeper. If you want to understand how ChatGPT, Claude, and GPT-4 actually work under the hood, this is where it gets really fascinating. We're about to explore the actual algorithms engineers use: greedy decoding, beam search, top K sampling, and Nucleus sampling. Don't worry, I'll explain each one so clearly, you'll be able to explain it to your friends. Ready? Let's dive in. First up, beam search. Imagine you're navigating a maze, but instead of following one path, you're following three paths at the same time. That's beam search. The AI starts with "the weather is" and explores three possibilities: sunny, beautiful, and nice. Then for each of those, it explores three more options: and warm, today, and outside. It's building multiple sentences simultaneously. At the end, it picks the path with the highest total probability. This is like having a team of explorers instead of just one. You're way more likely to find the best route. Beam search is used when you want high-quality outputs, like in translation or summarization. Now let's talk top K sampling. Here's the problem. If the AI considers all 50,000 words in its vocabulary, it might accidentally pick something ridiculous like aardvark after "the weather is." Top K says, hey, let's only consider the top K most likely words, say the top 5. So it filters out all the nonsense and randomly samples from just those 5 words. Simple, right? But there's a catch. Sometimes the top 5 words cover 95% of the probability. Great. But other times, they only cover 40%. Not so great. Fixed numbers don't adapt to the situation. That's where our next technique comes in.
Enter top P sampling, also called Nucleus sampling. This is smarter than top K because it's dynamic.
Instead of picking a fixed number of words, it picks the smallest set of words whose probabilities add up to p, usually 90%. So if the AI is super confident, it might only need 3 words to hit 90%. But if it's uncertain, it might need 15 words. This adapts to the situation automatically. When the AI is confident, it's more focused. When it's uncertain, it explores more options. This is what most modern chatbots use. It's the gold standard for natural text generation. Pretty clever, right? Okay, let's get mathematical for a minute. Remember temperature? Here's the actual formula. The AI calculates something called logits, raw scores for each word. Then it divides those by temperature T and runs them through softmax to get probabilities. When T equals 1, you get the original probabilities. Nothing changes. When T approaches 0, the highest probability word gets even more dominant. You're basically forcing the AI to always pick the winner. When T goes above 1, the probabilities get flattened. Now, even unlikely words have a better shot. Look at these examples. Low temperature turns 0.5, 0.3, 0.2 into 0.8, 0.15, 0.05. Super focused. High temperature turns it into 0.3, 0.3, 0.32, almost random. This one parameter controls so much of the AI's personality.
But wait, there's more. We've got 3 special tricks to make AI even better. Repetition penalty. If the AI already said a word, we divide its probability by a penalty factor. This prevents the AI from saying very, 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 very forever. Frequency penalty. We subtract a penalty based on how many times a word appeared. The more you've said it, the less likely you'll say it again. And presence penalty. This is simpler. If a word appeared even once, it gets penalized. This encourages the AI to use diverse vocabulary instead of repeating the same words. These penalties are why AI doesn't sound like a broken record. Now, you might be thinking, why do we need all this complexity? Why not just pick the best word every time? 4 reasons. 1, natural language. Humans don't speak the same way twice. If I asked you, how are you 10 times, you'd give 10 different answers. Good, great, fine, doing well. AI needs that same flexibility. 2, creativity. Without randomness, AI could never write poetry, tell jokes, or think outside the box. 3, diversity. Sometimes there are multiple correct answers. We want AI to explore different perspectives. And 4, trade-offs. Different tasks need different settings. Code generation wants low temperature. Your code needs to work. Creative writing wants high temperature. Surprise me. Translation wants beam search. Accuracy matters. Chat wants top P. Natural conversation. The complexity gives us control. Let's put it all together. Here's what happens every time the AI generates a single word, and this happens hundreds of times per response. Step 1. The model computes logits for all 50,000 plus tokens in its vocabulary. Step 2. Apply temperature scaling. Divide those logits by T. Step 3. Run softmax to convert logits into probabilities. Step 4. Apply top K or top P filtering. Throw out unlikely options. Step 5. Apply repetition and frequency penalties. Discourage repeating words. And step 6. Sample from the filtered distribution. Roll the dice. Step 7. Add the chosen word to the sequence and repeat the entire process for the next word. This happens in milliseconds, hundreds of times to generate a single response. Mind blown. So here's the answer to our original question. Why do LLMs give different responses every time? Because they use controlled chaos. Every word is chosen from a probability distribution, not deterministically. Temperature controls creativity versus consistency. Top K and top P filter out nonsense while preserving diversity. Beam search explores multiple paths for higher quality. Penalties prevent repetition and encourage varied vocabulary. And all of this complexity, why? It's what makes AI feel natural and human-like. Different responses aren't a bug, they're a feature. That randomness is carefully engineered to make AI useful, creative, and natural. Pretty amazing, right? If you learned something today, smash that like button, subscribe for more AI deep dives, and drop a comment. What should I explain next? Thanks for watching, and I'll see you in the next one.